So today we're going to start looking at quadratic equations. So far the equations you've been solving have had the highest exponential or the highest index of 1, and they're fairly straightforward. Looking at quadratics, what we're looking at is squared terms. So you can see some examples there. So anything that has the highest factor of a squared is called a quadratic. Now there's a few different methods we can use to solve it. We're going to show you two today. One of them is factorizing. So what that means is that if we know the two factors of a number, and we know that when we multiply those two factors, the answer is 0, then we know that one of the factors must be 0. There's no other way to multiply two numbers and get the answer of 0 unless one of them is 0. So when you get any one of these equations, the first thing you want to look at is, can I factorize it? So first step in factorizing, is there a common factor? In 3m squared plus 5m is equal to 0, we do have a common factor of m. So once you take that out, you're left with m outside of 3m plus 5 is equal to 0. So what that tells us is that some number times some other number is equal to 0. One of them must be equal to 0. So either m is equal to 0 or 3m plus 5 is equal to 0. Now, m is equal to 0, that's already solved, that's fine. 3m plus 5 is equal to 0, so then you solve that equation. So 3m is equal to negative 5, m is equal to minus 5 over 3. And you have two possible solutions to your equation. M is equal to 0 or m is equal to negative 5 over 3. Now, you'll find I underline when I get to the end of a question. The reason we do that is when people are marking it, it's much simpler to then find your answer, to figure out where you've stopped one part and started another, and to follow what's being done. So our next equation, 3x squared minus 13x minus 10 is equal to 0. So we're factorizing. We don't have a common factor. This isn't a special product. It's not a perfect square or the difference of two squares. So what we need to do is go to our cross method or product sum and factor method. I use the cross method because that's what works for me. So if we look at that, 3x squared has factors of 3x and x. Negative 10 is going to have factors of 5 and 2 or 2 and 5. 10 and 1 and 1 and 10. Remembering that one of these is going to be negative, but it's much easier to put the negative in after I've figured out what numbers I need to use. So multiply along the cross. 3x times 2, 6x, x times 5, 5x, 6x and 5x can't make negative 13x. So let's try the next one. 3x times 5, so that's 15x, x times 2, 2x. 15x and 2x, well, I can make negative 13x if I have negative 15x. So my negative goes there, and the factors of this equation are 3x plus 2, x minus 5. So once we know that it's either 3x plus 2 or x minus 5 is equal to 0, then we can say, well, that means that 3x plus 2 is equal to 0 or x minus 5 is equal to 0. So if it's 3x plus 2, then 3x is equal to negative 2 and x is equal to negative 2 over 3, or x is equal to 5. And they're the two numbers that if I substitute back into my equation, 3x squared minus 13x minus 10 is equal to 0, would make it true. So if you were given an equation and the terms aren't all collected on one side, you just move them across and so they are. So we're going to move this so that we get 2a squared plus 13a minus 7 is equal to 0, because then I can factorize that. 2a and 7 is easy because it's 7 and 1. We've just got to figure out which combination is going to make 13a. We've got a negative 7, so one of them is going to be negative and one of them is going to be positive. So 2a times 1, a times 7, it's only going to get me 9a. 2a times 7 is 14a, a times 1 is a. So if I make that one negative, I'm going to get 13a. So 2a squared plus 13a minus 7 is equal to 0, factorizes to 2a minus 1, a plus 7. So we make that all equal to 0, which means 2a minus 1 is equal to 0, 2a is equal to 1, and a is equal to a half. Or we can say, well, a plus 7 could equal 0, in which case a is equal to negative 7. Now again, whenever you're solving these equations, you can go back and check if you're right or wrong. You don't need to wait for the end of the test and getting the answers back from me. You take those values, substitute them back into your equation. Put in half, 2 times a half squared, plus 13 times a half, you'll get 7. So another method we can use is called completing the square. And this will often work when factorising doesn't. So if you look at the equation x squared plus 10x minus 2 is equal to 0, there are no factors of negative 2 that I'm going to be able to combine with the x's to make 10x. I can't factorise this to find a solution. But what I can do is figure out what squared term would give me an x squared plus 10x. Okay, so what this works on is that idea that x plus a all squared expands to x squared plus 2ax plus a squared. So what we need to do is figure out what I need to put in here that would give me 10x. Well, I know it's twice the product. It's 2 times the x times the a. So 2a is equal to 10. So a, the number that I'm going to put in there, must be 5. But what I don't have is a squared. I don't have 5 squared or 25. That's what I'm going to put back into my equation. So the first thing you do when you're completing the square is you take the constant term and you move it across to the right. We know that x squared plus 10x is equal to 2. And then you have to look at it and figure out what term needs to be added on to x squared plus 10x so that it would be a perfect square. So that's what we were just looking at. What you do is you take the coefficient of x, the 10, and you halve it. So half of 10 is 5. Then you need to add 5 squared onto each side. Because once you've done that, you can then factorise the left-hand side into x plus 5 all squared. So x plus 5 all squared is equal to 27. So you've completed the square. Then you use the fact that, well, if x plus 5 all squared is equal to 27, then x plus 5 must be equal to plus or minus the square root of 27. You've got to take into account the negative. So if x plus 5 is equal to plus or minus root 27, then x is equal to minus 5 plus or minus root 27. Now we've done surds, so you should be simplifying root 27. Square root of 27 has the factors 3 and 9, so that is going to be minus 5 plus or minus 3 root 3. Now if they ask you to give your exact answer or in surd form, that's where they want you to stop. Okay, so another practice on the same concept of completing the square. We're going to start with y squared minus 14y, and we move our constant to the other side. So then look at your middle term. We've got negative 14y. So you've got to take into account that minus. If there is a minus in the middle and we're making a perfect square, then we're going to have y minus something all squared. How do we work out the something? Well, you halve the middle term. So half of 14 is 7. So we need to add negative 7 all squared. Because that way, when we factorise it, it factorises to y minus all squared is equal to, now be very careful, negative 7 squared is 49, not negative 49. Be really careful with that. That trips students up when they're not paying attention. So if y minus 7 all squared is equal to 46, then y minus 7 is equal to plus or minus the square root of 46. So y is equal to 7 plus or minus root 46. Now, that's exact answer or surd form. If they wanted it to decimal places, then you would type that into your calculator, 7 plus root 46 or 7 minus root 46. That's what you need to have a go at exercise 3.7 and 3.8. So have a go. If you don't understand, come in and ask me. Good luck, and I'll see you in class.